Okay, so let's move on to integrating. This is going the other way now. To get the displacement, we integrate the velocity. If you remember my diagram right at the start, we differentiate to go down. We differentiate to go from displacement to velocity to acceleration. When we integrate, we go from acceleration back to velocity, back to displacement. And that's because integration effectively undoes differentiation. It's exactly the opposite. Okay, so integrating takes me from the acceleration to the velocity to the displacement. There's a slight added complication in integration in that we need to find the integration constant. We don't have to worry about that in differentiating, but when we integrate, we have to find the constant that was lost when we differentiate. So I'll show you some examples of doing that. So the acceleration of a particle is 3t plus 5. And I've given you, to find the integration constant, we have to be given some extra information. And that's why I've given you this. I said at t is 0, the velocity is 8 meters per second. This is the hint we need to work out what the integration constant is, as you'll see in a second. So first of all, it just says find the acceleration at t equals 0. That's really easy. We've got an expression for the acceleration. It's here. Substituting t is 0. It just gives me 5 meters per second squared. Okay, nice and straightforward. Now find an expression for the velocity. Now remember, to go from acceleration to velocity, we need to integrate. Okay, and that's because velocity is acceleration integrated with respect to t. Okay, so I need to integrate 3t plus 5 with respect to t. If I do that, I get 3t squared over 2 plus 5t, and don't forget an integration constant. We'll call it c for now. Okay. Now, how do we find this integration constant? So this is the integration constant here. So this is just standard integration, just like we did in pure maths. So how do we find the integration constant? Well, look at the information we're given. We were told that at t equals 0, v is 8 meters per second. So I can substitute that in. I can say, well, I know that v equals this, 3t squared over 2 plus 5t plus c. So I'll substitute in. I'll say, well, v is 8. 3 times t squared, which is 0, over 2, plus 5 times 0, plus c. And I can now solve this equation to find what c is. So those bits both go to 0, so I just get 8 equals c. Okay, so c is 8. So my full expression for the velocity is v is 3t squared over 2 plus 5t plus 8, because we just found that c is 8. So just to run that through again, if you didn't quite follow that, I figure out an expression for the velocity by integrating. I've got this integration constant which I need to find. I look in the question for some extra information. It says at t is 0, the velocity is 8. I can substitute those into my expression for the velocity, which is what I've done down here. I put v equals 8 and t equals 0. And now I've got an equation I can solve for c. And by solving that, I get c is 8. I put that back in for c, and that's my full expression for the velocity, and that's the final answer. Okay, including the integration constant. And finally, find the velocity of the particle at t equals 2. So this is just using the expression we've just found. We just found that v is 3t squared over 2 plus 5t plus 8. So if I substitute in t is 2, and tidy everything up, that gives me 6 plus 10 plus 8, which is 24 meters per second. Okay, so at time t equals 2 seconds, the velocity is 24 meters per second. Let's do another integrating example. This time I'm giving you an expression for the acceleration. I said a is minus 3 over 2t plus 4. And I've said at t is 0, and look at this is the information we need to find the integration constants. T is 0, the velocity is 4 meters per second, and it's 2 meters from the origin. So what I've said there is at t equals 0, v is 4, and s, the displacement, is 2. Okay, that's the information we're going to use to find the integration constants. In this case, we're going to need 2. So find an expression for the velocity. So remember, to go from acceleration to velocity, we need to integrate, because the velocity is the acceleration integrated with respect to time. So I'm going to integrate my expression for the acceleration. It's minus 3 over 2t plus 4. I'm going to integrate that. When I do that, I get minus 3/4 of t squared plus 4t plus an integration constant. Okay, and I look at my information and say, well, okay, at t is 0, v was 4. So I can substitute that in. This is my v here. I can say, okay, well, v was 4 when t was 0. So I'm just going to substitute all that into the equation and simplify it down. So these first two terms go to 0. So I just get 4 equals c. So my c is 4. So I can write out the expression now. V is minus 3/4 of t squared plus 4t plus 4. There's my expression for the velocity, include the integration constant. And the next bit says find an expression for the displacement. Well, how do I get the displacement? I can get it from the velocity. To get to the displacement, I need to integrate again. To get from velocity displacement, I integrate again. Okay, so the displacement s is the velocity integrated with respect to time. So I'm going to substitute in the expression for the velocity, which I just found. That was minus 3/4 of t squared plus 4t plus 4. Put some brackets in to make that clear. Integrate with respect to time. So if I integrate that one, I'm going to get minus 1/4 t cubed plus 2t squared plus 4t plus a new integration constant. I'm going to call it something different just so we don't confuse it with that c, but you can call it whatever you like. I'm going to call it d for argument's sake. Okay, so I know I integrated that very quickly. I'm not doing a lesson on integration here. I'm just kind of assuming you're happy with doing this. If not, do have a look at the lessons on integration, just to give yourself a reminder how it's done. So now I've got that, I need to find this integration constant d. I go back to the information I found, and I found that at t is 0, s is 2. So I can substitute that in. I can substitute s is 2. This is my expression for s, remember. Equals minus 1/4 of t cubed, and t is 0. It's 2t squared, again t is 0. It's 4 times 0 plus d. And you can see from all that, I just get d equals 2, because all of these terms are just 0. So now I know d is 2, I can write out the full expression. I get s is minus 1/4 t cubed plus 2t squared plus 4t plus 2. And there it is, there's the final answer for the displacement. Biggest thing, as I said, with differentiating is just remember what order everything goes in. When we integrate, we go from the acceleration to the velocity to the displacement. And every time we integrate, we need to find the integration constant. To get that, there'll always be information given to us in the question, okay? There'll always be some velocities or some displacements. There might be hidden ones. They might say things like at t equals 0, the particle is at rest. That means at t equals 0, the velocity is 0 as well. So look out for things like saying it's at rest. It just means the velocity is 0.